I'm going to talk about state-of-the-art for solutions for IDE support. My name is Florian Berchtold. I'm principal software engineer at Zipline, a logistics company which has just achieved 120 million miles flown in Africa. We're one of the largest commercial drone operators in the world. And we have a small monorepo. We actually call it big monorepo, but you guys, from our perspective, it's a big monorepo. So what do we get with Bazel? We get hermeticity, we get fast builds, we get caching, remote caching, everything is amazing. If we implement everything that we heard today, CI is fast and whatnot. But what do developers do on their machines? They don't have access to those hermetic build tools. They don't have access to all the integration. So what we're missing is the tools, the tool chains, the utilities. They're not straight out of the box available on your developers' machines. Developers don't like to run Bazel, run at AWS, what was it again, the repo, colon, forgot about it. They want to type AWS and do their stuff, right? And also IDEs rely on the tools being on the path. We're going to talk about one way, an amazing way to do this. And once we have that, we still have the IDE support that is not great because IDEs need language servers. IDEs, Bazel supports, I don't know, dozens of languages, and it's often hard to integrate them with our IDEs. And projects such as the build server protocol are in progress, but not fully ready yet. So let's tackle the first problem, the tool support through Bazel itself. There's an amazing project from, he should show up here, Fabian, of course. Thanks, kudos to him. The bazel-env. So what is bazel-env doing? It utilizes a, I don't know, 20, 30-year-old tool, which most of you might know, direnv, which will automatically source a .nvrc file once you change the directory into a certain folder. And it's really easy to integrate, and what it does, it will create path entries for all of your tools, for all the hermetic tools that you downloaded. It will make them available for your developers to run through the well-known aliases like Python, AWS, Cargo. And the only thing that your developers need to do is run Bazel run tools bazel-env, and they get all of the support. How does it look like? The way it's being configured looks like this. This is just a very basic template. You have a few tool chains that you have specified in your module.bazel file. In our case, JQ, Python, and then you have other tools such as Cargo, which is utilizing a wrapper and needs to be compiled, for example. We have Rust format, SHA-SUM, like this is just an example. And then we pipe in multi-tools, which is just the straight out of the box set of tools that come with bazel-env. So now we have all the tools on the path, right? So your developers will not face issues like, oh my gosh, I'm using Rust C 190 and the CI is failing. Oh, it's using 185 or whatever. So your local development for those use cases where developers need to rely on something outside of Bazel, and then Rust in our case is such a good example because some profiling are not supported by rules Rust yet. These problems will be gone. Developers will not see a huge difference for them once they ran it once. They change in the directory and they have all those aliases available. But the IDE is not supported yet. So how do we get IDE support? Bazel supports the IDEs through Bazel. So let's do that. We chose dev containers. I don't know, many of you might use VS Code /cursor, all the other derivations of it. And it can help you with automating a lot of this. You start a dev container, you have it automatically set up your bazel-env, what we had before, and then you install the IDE extensions. Bazel can also support you with StarPLS, a language server for Starlog, and it's out of the box already part of bazel-env. And there's also a Bazel build VS Code Bazel integration, which will then help VS Code, for example, to find the StarPLS server. C++, how do we do it for C++? We have the compile commands extractor to get your compile commands JSON file, which can then be consumed by most IDEs coming back from CMake. We have clangd, the daemon to give you language support for C++, and of course the Visual Studio extension. This works okay-ish for most of your smaller repositories, but try create a compile commands config.json for a monorepo. And for this example, there's a bazel-compile-commands-extractor, which can also build it for specific targets or folders. So what this means is that your IDE can now help you by you navigating to files, figure out where is your developer focus right now, and give you that specific scope/context as a C++ completion, like auto-completion. And this is kind of the generic recipe, how we approach it. You look for a given language, you have to figure out the tool for the language support. Once you have that, could be, for example, clangd or something else. If you're lucky, there might be an optional language server available. Put it into the bazel-env, you have it on the path, done. Find an IDE extension that supports the language server or the language out of the box. Python is a good example where you don't really need a huge language server. And you have that interface between IDE and language solved. And for large code bases, try to find a way how to reduce scope, because you can't, I know the big monorepos can't even analyze the whole code base at one given time. Don't even ask your IDE to give me the index for my whole code base. And that's really it. I know it's a quick one, but it's also the last one for lunch, so I hope you're not too bad on me. We have a few examples here. Marcus, my colleague, he worked a lot on this. And yeah, quick gig. We're looking for DevOps engineers. Thank you.